Hello friends, and welcome to Escaping the Mouse with your host, me, Breck Rowell. Alright, I'm going to nerd out a little bit because I want to talk about something that appeared in the news, about a week ago from my perspective. It was kind of an interesting piece of scientific news. Apparently, there was a big, what they call a coronal mass ejection on the sun. Now, coronal mass ejections, we sometimes think of them as solar flares, and I'll show you some video of solar flares right here. But basically what it is, it's a high energy plasma that's coming off of the sun, usually erupts out of sunspots. And this one was particularly interesting because it fired right at the planet Earth. Now, solar winds and solar flares are a common occurrence on the sun. Actually, they go on an 11-year cycle. And so sometimes there's very little sunspot activity, other times it's very active. Now, you may recall about 3 years ago, I went out and I found out that there was going to be a total solar eclipse. It's going to cross right through the middle of Waco in about a year and a half. And I found out about that about 3 years ago. And I decided at that point, I wanted to go out and buy what they call a folded Keplerian telescope. And I did a vlog about that at the time I got it. But at the time, there was really no sunspot activity to look at. But when I heard this news report, I said, okay, that's cool. I'm going to pull out the solar telescope and I want to look at this thing. And then we're going to talk a little bit about what happens. Now, with these coronal mass ejections or solar flares, what ends up doing, like I said, it fires high energy plasma at the Earth or out into space. In this case, it's aimed right at the Earth. And this can be dangerous at sometimes because the radioactive and highly electrically charged and magnetically charged particles can literally fry the electronics in satellites, and it can even cause disruptions with communications. It could fry on bad enough conditions that could actually fry electronics on the ground. Now, this isn't going to be one of those things. This is a very low power CME, or coronal mass ejection. But like I said, it was an opportunity to look at one of these things up close using my own telescope. Now, one of the cool things that comes from the solar winds and CMEs is when they hit the Earth's magnetosphere, which is the part of the Earth that causes our magnetic poles, our north and our south pole, that we use for using, when we look at compasses, that's what we're reading. It's basically an electrical field generated inside the center of the Earth that's like the poles of a magnet. And what ends up happening is when these highly charged mosquito. What happens is when one of these highly charged fields of energy hit the magnetosphere around the Earth, they get pulled to the poles, and that is what causes what they call the aurora borealis. It's basically high energy particles bouncing off the magnetic field and creating these beautiful, colorful patterns that you see in the sky. But since I have this telescope, I decided I wanted to really open it up and look at it and get a look at this sunspot. And maybe we'll talk a little bit about this thing and learn a little bit more about what's going on. So this is that folded Keplerian telescope that I bought a few years ago. And like I said, I looked at the sun at the time and couldn't really see anything because there was no sunspot activity at the time. But I pulled it out and looked at the sun just a few minutes ago, and actually I can see the sunspot that's causing this thing. So right now it's a little bit cloudy, so I'm going to wait for the clouds to burn off a little bit. We're going to re-aim this thing, and we'll take a look at the sun. Like I said, it's a little cloudy up there right now, so we're going to have to wait for the clouds to cooperate and get out of the way. Now, when it comes to looking at the sun, you want to be really careful. You don't want to look at the sun directly. You definitely don't want to look at it through a pair of binoculars or through a traditional telescope, because it will cause permanent eye damage. And so you got to be very careful. You want to use something that's really designed for it. They've got filters that you can buy that that you can use to look through it. Sometimes people use welding goggles to look at the sun. Or you can use something special like this. And basically what this is, it's a series of lenses and mirrors that project the light all over the place in here, and then ultimately project the image onto a sheet of paper. And that's what I'm using. I'm going to line this thing a little bit careful here. And if you look here, you can actually see right there is the sunspot that we're talking about. It doesn't seem like much, but what's going on right now is that there's an enormous amount of energy coming off of that thing. And as I said, when it was first discovered a couple of days ago, about a week ago, I guess, it was pointed right at the Earth. Now, like I said before, this can cause problems because the energy and the electromagnetic field coming off of these things can create electrical charge, which, like I said, can fry electronics. It can actually, cut out communications on Earth and all sorts of weird things like that. So you want to be really careful with these. Now, it turns out there's about 3 different levels of these energy bursts, or CMEs, that come in, and this one is actually the lowest level. But it did still have the power to knock out a satellite, a weather satellite in Earth orbit. So, even the little less powerful ones can cause problems. But check that out. You can actually see the sunspot right there. I'm hoping you can see that on the camera. It's very, very clear on the surface of the sun. And this is kind of exciting because this is the first time I've actually looked at used this thing and looked at the sun and actually seen a solar flare and a sunspot. I've seen these things before. I remember my parents and I and family were in Yosemite one time, and my dad and I went on a hike, and there was a guy that had one of these out there kind of in the middle of nowhere, and he was looking at the sun, and that was the first time I'd ever seen one of these things. And so I've been aware of them ever since. But like I said, I picked up this one a couple years ago, and this is the first time I've actually been able to see a sunspot with my own telescope. So that's kind of exciting. Now, sunspots themselves are actually sort of an interesting phenomena. The sun has magnetic poles just like the Earth does, but since the Earth is a solid object, well, at least on the surface, there's a north and a south pole. But since the sun is just a radioactive ball of gas, it's actually twisting around, and so the magnetic field of the sun isn't nice and ordered coming out of the north and south poles like it does on the Earth. It comes out all over the place, and it's twisting around, and every time one of these magnetic fields passes through the surface of the sun, it creates one of these sunspots. And the sunspots then with the electrical field, the electromagnetic plasma coming off the sun follows these magnetic fields out into space, sometimes millions and millions of miles out into space, and they fire off these highly charged energy particles in whatever direction the sun is pointing at the time. And like I said, that is what's happening here, and I just thought that was really interesting, and I wanted to talk a little bit about that. Now, initially scientists were a little bit concerned about this thing because it appeared just about a week ago, and in a very short period of time it grew in size massively. They said in the period of a couple of days it grew to like 10 times its original size. And so the fact that it grew so fast, it appeared so fast and grew so fast, and then was pointed right at the Earth, like I said, scientists were initially a little bit concerned about this. Now, like I said, it did cause a little bit of damage, I believe, on a weather satellite, and probably those of you in the north are going to get some pretty impressive aurora borealises to look at, and those can be very, very beautiful. But that is evidence of a lot of the very interesting things that are happening on our sun. So I hope you enjoyed this one. This was kind of a little bit nerdy, but you know what? I do that sometimes. And I think that's all that I have for today. So thank you as always for watching. And I'll see you next time on Escaping the Mouse. Good night. CMEs aren't affecting you, are they, Flash? Just gonna go out and find something to eat. Now, just as a side note, in the maybe 10 or 15 minutes I was outside shooting this video, I got eaten alive by mosquitoes. Mosquito activity has been very, very low this year, probably because of the drought that we had. There's just not a whole lot of places for them to grow, because they usually require standing water to go through their early phases of their life. Well, we had rain about a week ago, and all of a sudden the mosquitoes are out in force. So yeah, I got eaten alive for this one.